Alright, so you might have run across a problem like this one, where you have three variables, three unknowns or three variables and three equations, which is a three-dimensional, basically three planes in three dimensions. And you wonder why it has no solution. So I'm going to show it algebraically, but I also want to show it in GeoGebra. Well, there it is, but GeoGebra.org is where I'm building this. I've shown this in a couple other videos. There it is. And so here's the three equations. I went ahead and just stuck them in the input, just typed them in, and you can kind of, I'll hold this to the side so you can see they're the same. So the top one I made purple, the middle one I made red, and the bottom one I made blue. And so when you graph those three equations, this is what you have. And let me kind of shrink this down to fit in the screen better. And so we'll rotate this around so you can see what's happening. So when you rotate this around, you can kind of see right in this area, in this region, the purple plane and the blue plane, even though they intersect the pink plane, the intersection lines on that pink plane are parallel. So those two planes will never intersect. And so, well, they do intersect, but not on the pink plane. So let's put in those lines. There's that one. There's that one. And maybe that'll help us kind of see it better. So yeah, so there you can really see those planes and those intersection lines and how they are parallel. So we're never going to get these two planes to cross on the pink plane. They cross somewhere. In fact, maybe we can even see where they cross. Yeah, well, they cross on that line right down there at the bottom on the underside of this graph. It's kind of hard to see, but kind of make you a little sick. But anyway, so those two planes, this left one and this right one, will not intersect the pink one in one location. So maybe I've said that right finally. And so those are so that's what it looks like algebraically. Now, if you think back to when we used to do this, I'm going to flash back, and we had no solution when it was just two variables and two unknowns, and it's an equation like this one. So 2x minus 3y equals 6, and 6x minus 9y equals 9. If you simplify this, basically these two numbers are the same because you have the same slope and you have parallel lines. So let's look at those in GeoGebra. So let me go back to start creating. I'll start one from scratch here, and we're going to go into let's go into the three-dimensional system. This is kind of neat to see. Oops. So we're going to graph a 2D and a 3D system so you can kind of see what that looks like, just for something new. We'll go ahead and put it in the input. So 2x minus 3y equals 6, and 6x minus 9y equals 9. And there it is. It graphed those. And you can see that it's, if you get rid of if you look at the plane from straight above, like what we're used to in an XY plane, you can see, let's see if I even got it oriented right. Yeah, there you go. So there it's oriented correctly. You can see it's two parallel lines. They're not going to intersect. And you could prove that pretty quickly. So this is an inconsistent system. No solution, parallel lines. So in a three-dimensional system, it looks a little different. It's hard to even see that occurring. And so I'll show you algebraically now how you end up with no solution. Okay, and so what I'm going to do is I'm going to go back to that original equation, the no solution situation, and we'll use elimination just to kind of show that. Hopefully by now, if you're working with three equations and three unknowns, you've worked with elimination a lot. And so we'll match up our x's to eliminate them. So you would multiply this top equation by a -3, okay? So that we get -6 and 6, so when you add them you get 0. So you'd have -6x plus 9y equals -18. And you'd have 6x minus 9y, you don't have to do anything to this bottom equation, equals 9. So when we add these down, you would have 0 here, those cross out, 0 here, those cross out, and so 0 equaling -9. Well, that's false. That can't happen. So you know that the line is parallel when you get that. The lines are parallel, and there's no solution to this equation. So let's see if we can find some similar situation in the 3 by 3. So we'll just eliminate our, let's just eliminate our x's. We'll look at the top two, and we'll eliminate the x's. So we'll take the top by -3 and the bottom by +4 in order to make a -12 and a +12. So you'd have -12x plus 6y minus 15z equals -18, and 12x plus 12y plus 32z equals a 16. We'll add these down. -2, these cross out. 12y and 6y is 18y, getting kind of late in the day. Brain isn't quite working as quickly. And -15 plus 32 is 17z, unless I'm mistaken there. So it looks pretty normal so far. So there we eliminated that. We've gotten 18 plus 17z. Equals -2. So now let's look at the bottom two and also eliminate our x's and see what happens. And so in this case, we're going to multiply this bottom, and I'll do it in red. We're going to multiply this bottom by -3 to match up our x's. Okay, and I need to move this over a little and down a little so I got a little more room to work. And so you'd have, I'm going to leave the top alone, so 3x plus 3y plus 8z equals 4. The bottom I'm multiplying by -3, so -3x plus 15y plus 9z equals -15. You add down, these cross out, 18y, I'm starting to see something repeating here, plus 17z equals a -12, 11, like say, getting late in the day. Sorry, my arithmetic goes downhill quickly at the end of the day, just like many of you do. And so you combine these two now, and you're going to see what happens. Notice the 18y, let's match up our 18y's. We could multiply this bottom equation by -1, and lo and behold, so 18y plus 17z equals -2, and -18y minus 17z equals 11. If you multiply it by -1 and you add down, and you end up with 0 equaling 8, which is false, which means we got a parallel line, set of lines somewhere. And so when you do these no solutions in a plane, you end up with a very similar situation as when it's just in 2 dimensions. So there you have it. I hope this helps you when you're exploring these, because you'll probably run into one or two like this. And the best of luck, and see you next time.